systems graphically, what would be the easiest way using technology to solve a 2x2 linear system, do you think? What would you do? What would you do in Desmos? Graph it. Absolutely, right? Like if you want to solve a system, if you want to find solutions. Now this is, okay, let me preface this. This is real solutions. It's not going to be complex solutions with imaginary parts. I mean, there are different things you'd have to do for that. But if we're limiting ourselves to real number solutions, which a lot of times we do, then the easiest way to find solutions to a linear system involving two equations and two variables would just be to graph the thing. Like, for example, what about this guy? Right? If I want to solve this system, I would just pull up Desmos graphing. And look for the intersection. Nice thing about Desmos, you don't even have to solve for y. In your graphing calculators, you would, which is a little bit of a downside of graphing calculators. There are better technologies for finding solutions in a graphing calculator. So there's my solution right there, right? It's just the point of intersection, okay? What happens if you have something like, oh, not that. Okay, where is it? 512. Okay, we'll pull those up. Yeah, here it is. Okay, what about this one? So if I want to solve that system, same thing. There's a practical consideration here we're going to run across, though. Okay, what's the solution? How come? Okay, because they don't intersect, right? Okay, but what if this was something like, oh, let's say, what's that solution? No solution, right? Are you sure? Okay, yeah. So there is a way graphically, and I'm going to show you a better way of doing this with Well, I mean, you guys know how to do this stuff using matrix row operations, but I'm going to show you the shortcut today where you can let any matrix calculator do all the row operations for you and put the matrix into reduced row echelon form with one push of a button, which is a pretty handy thing. So if you're relying on graphing technology to do this one, they look parallel, but they may not be. So here's the way in Desmos, for example, you can tell if they really are. If you click on one of those lines and I zoom out, you have to click on one of them. If I zoom out, tell me when you recognize that it is not. Exactly, look there, right? If you click on one of the lines, remember what Desmos does. Desmos gives me suggested points for any place that's an important point. What are those? Well, they're X and Y intercepts. A lot of times they might be things like the minima and maxima of curves or intersections of functions, right, of graphs. Well, there's an intersection. So that's telling us that no, the solution to this linear system is not no solution. There is a point of intersection that I can find if I keep zooming out, right? Everybody see that? Okay. We can also do stuff on here that's, we don't have to limit ourselves to exclusively linear equations. We could do systems like this system, somewhere is my system, that are nonlinear. Doesn't matter, that's fine, we can do this. All we have to do here is just go in and type in these equations, but instead of lines, they're just going to be curves. Again, and it's so nice in Desmos to be able to write these as implicit equations where they're not, there's not a variable that's isolated. So I'm going to hit the home button to go to the home screen where it zooms in, and you can see how many solutions should I expect to this linear system. 3, yeah. There's one, and there's one. Okay, easy. All right, so that's one good way to solve systems quickly. Okay, here's another way. What if you've got a system, a big linear system like this, which you can't graph? That's a 4-dimensional linear system. I double dog dare you to graph that one because you'd have to graph it in a 4-dimensional space, and good luck with that. Okay, we live in a 3-dimensional universe, so you might have some trouble with that. But there is a way to do this using matrices. You guys could do the row operations and solve this. If we're starting with this matrix, we would just convert this into or with this linear system, I could just convert it into this augmented matrix, right? So what's the meaning of that first row? Yeah, it's just telling us 1x plus 1y plus 1z plus 1w equals 6. There it is, right? So you guys can do all that. And you could do, I know this is a 4x4 system, but you could do the same row operations that you did with 3x3 systems to solve this one too. It'd be no big deal, right? We'd have to just work our way at the bottom. We want that to be 0, 0, 0, a number, 0, 0, a number, 0, a number, right? And if you want, that would be row echelon form. And then you could just back substitute and get the answer pretty easily if you could get it into that form. Or even better, you could put it into reduced row echelon form, where you'd end up with numbers on that diagonal. Everything down here would be zeros, all that stuff would be zeros, and then you just get numbers there, right? Which is what you can do with Desmos matrix very, very easily. Here's how you do it. If we go into Desmos matrix, so here's Desmos matrix. Go into Desmos matrix and enter that, right? We want to enter the augmented matrix corresponding to the system. So I would do new matrix. I need to have bump the rows up to 4 and the columns up to 5. And then I'm just going to enter that. Oops. So there it is. Agreed? Let me make this bigger. Okay, now all I've got to do here is, I made that too big, I guess. I have to just go down to, I have to hit enter. Whoops. There you go. Okay, now I'm going to go down, now that I've created that matrix, that's matrix A. So if I type matrix A and just hit enter, look what it does. It just returns that matrix, okay? I'm going to go down to the RREF button, reduced row echelon form, and I'm going to input matrix A, and look what it did. It gave me that matrix in reduced row echelon form, right? And there it is. So what is that telling me? Okay, we will get back to this tomorrow. How about?